Hello everybody and welcome to another mystery box function challenge. In the purple box there is some mystery math and your challenge is to figure out what it is. You can use the link in the description to try this out, and when you think you've got an idea, come on back and see if we get the same thing. Okay, let's start with a 0. So 0 gives us, looks like a negative infinity as an error. That's interesting. So at 0, it's probably approaching infinity in the negative area here, from one direction or the other, I suppose. Let's try a 1. And 1 is 0. Okay, 2. And 2 is some, looks like a non-repeating decimal there, which might make you think square root, but that negative infinity makes me think something else. Let's try a couple more along here. Let's try a 5. Maybe we'll go all the way out to 10. Oh, that's interesting. That's probably going to be a useful point. And let's try some fractional values. Let's do 1/2. Okay, let's try maybe 1/5. Let's see, and let's try 1/10. Okay, that's going to help too. So the thing I'm thinking right now is logarithmic function. They have that shape where there's a long tail that goes down and approaches the y-axis but never quite gets there, and then an arm that goes off to the right here, getting more and more shallow as it goes out. That's your typical shape of the logarithmic function. And it might be that this is the log of some base, and we need to determine the base. The most common ones are log 10, that's called the common log, or the natural log. But we also, it's possible we have a multiplier on here, and I'm thinking that's probably the case just by looking at the kind of squished-ish shape of it that I'm seeing here. So let's think about this. First of all, let's just review logs a minute, just so we can wrap our heads around this a little better. So if you have a base and you raise it to a power b, you get some result. So 10 to the second power equals 100. The log goes like this. You have a log of that particular base. So that's your base here. That's the base of the log. And the result, well, I don't know why I wrote y there. Let's write c, ABC. That makes more sense. The result here is the log base AFC is going to give you the power b. So what we have to remember here is the powers we're getting out. Okay. And what we're putting in here is really this this result that you get from raising something to the base. And we don't really know the base here. The most common is base 10, and that you just write as log of x. And if this was the log base 10 of x, what I would expect is that at 1 we would get 0, and that's what we're getting here. So this is a point you see on logarithmic functions. You put in 1, you get 0, because anything to the 0 power, remember this is the power, anything to the 0 power gives you a result of 1. And then we've got this interesting point at 10 and 1/10 that are maybe a little easier to figure out. If this was the log base 10 of x, at 10 what we would get out is a 1, right? Because 10 to the first power is 10, so the log base 10 of 10, the power would be 1. But we're getting 1/2. Now, when I did 1/10, I got negative 0.5, and this made me think we might have a multiplier of 1/2. And let me explain that with the 1/10. So when we take the log base 10 of 1/10, we ask what power are we raising 10 to get 1/10, and that would be negative 1, and we got negative 0.5. So it looks like maybe we're multiplying by 1/2, and it looks squished, so I think multiplier. Let's think of another point we could get. What if this is 1/2 times the log base 10? What if we put in I don't know, 100? So 10 to the second power is 100, and then we'd multiply that by 1/2. So that'd be 2 times 1/2, so that should give us 1. So if we put in 100 here, we should get the number 1. And we won't see that on the graph, but we can see it on our chart. And there we got a 1. So I'm thinking we've got this. Let's go ahead and look. Yeah, 1/2 times the common log or the log base 10 of x, and we can graph that as well. And there it is. You can't even see because it starts to go down so fast. It doesn't get plotted by my plotting function here. But then you have that long, shallow arm going out there. Well, how did that go for you? Did you think logarithm? Let me know. Thanks, everybody.